And good evening, everybody. Sorry, I know there was, whoops. I know there was a little bit left on the timer. However, I also know, I'm going to fix that camera here in 1 second. I also know that I got that timer started just a tad bit late. So there we go. Welcome on in, everybody. Welcome back into the Dragon's Den. My name's Digital Dragon. I'm a 3D printing variety streamer here on Twitch. So welcome on in, everybody. Chewy, welcome in, and thank you for the 18 months. Yeah, how time flies. That guy makes, welcome in. Mr. Wizix, welcome in. Hope everything's doing good. Reverse Wilson, exactly. Folks, give me 1 second. I'm going to check the thermostat in here right quick. Okay. Just making sure that the thermostat set where I was expecting it to be. So I hope everybody's doing well. We got our coffee. So we're, when I say we're, me and my other personalities, we're doing good here. We're caffeinated now. Though I did just run downstairs and take some Dayquil, so we're going to see what Dayquil and coffee taste. It is not snowing here, Chewy. A little bit further south, as in down in North Carolina. But yeah. Before I make any more hand gestures, let me turn. What do I need to do? Turn something up. Turn off human traffic. There we go. Sorry, we got the new OBS bot, and for right now, I just don't want it tracking me. Just because I tend to talk with my hands, and I do something like that, and it decides to start moving around on me. That storm is huge, though. It was not snowing down here. I'll check my thing. (10 miles per hour) wind, yes. Precipitation. It's 48 degrees, so it's cold, dark. Who can do it? Give me a forecast. Yeah, it's not loading yet, but I'll give it a couple of seconds and see where it shows up. Yeah, cold and balmy. Exactly. Cold and balmy. I'm getting a little warm right now, believe it or not. It's temperature says it's 70 up here. It's probably the fact that I just took Dayquil and then was running up and down stairs a couple of times trying to get things like, you know, I was working on a couple of things, getting the bed plates prepped, like I said I would, and I also got into our electronics box here. Yeah, I don't know. According to my thing, there's like no weather whatsoever around. So I know that's wrong. Put that off to the side. But we were getting the electronics box a little more done. No, you don't have my maker chip. Um, Maybe that guy makes. Not all of my maker chips are right there. I started to print another one to put the ones that we got from 3D Printopia, and I'm going to reprint it because that one, the overheads, excuse me, turned out like crap. So we still have a bunch more downstairs that we still need to open up and get out. Yeah, I'm gonna have to get these boots off. So I'm the type of guy that if my feet are cold, I'm cold. If my feet are hot, I'm hot. So as I'm starting to get hot here from doing a little bit of running up and down the stairs real fast, and then taking some cold meds. Taking the shoes off will help. But what I was trying to say before was we did a little bit more work on the electronics box. And you're going to say, well, really, what work did you do? So this is where we finished off last stream, right? We've got our 2 umbilical cables that are coming out and around. One that's has all the sensors and the E-stepper, and the other one is the rest of the steppers. And what I did was I took the Raspberry Pi out and put heat sinks on everything, and then put the Raspberry Pi back in, and got mad at myself because the whole purpose of taking the Raspberry Pi off wasn't necessarily to put the heat sinks on, but to stick the SD card that I flashed in the back of it. So I wound up just taking the back panel off, shoving that SD card in there, and putting the back panel on. I also put 1/2 of the umbilical chain or umbilical strain relief right here. We'll do the other one. There's one more cable that we need to run, which is the power. And once we get that run, we should be good to go to start buttoning this up. One of the other things that I did was reprinted this piece, and you can see that this piece, or this side, which was down on the bed, had good adhesion and printed just fine. And it is in the secondary color. This is the Cookie CAD Midnight Magic ABS. So we got that bonded on there now. So the door's ready to go. We got the top and the door that we can add to that once we're done. And then, as you can see, we have a few things ready to go. You haven't got one of those to print properly. The key is to have good cooling, and I'm going to say a well-tuned profile. So the one that I printed over here, I think I printed that on a Voron. Double check the bottom. Well, that's smooth. So this was either on a Bamboo or the Prusa, actually. The other one I printed on the Rat Rig, but the Rat Rig has a 0.6 nozzle, and the overhangs did not do good at all. So, but these are some of the things that we're going to be using to get the stream started. So we've got our gloves because we're going to be working with some epoxy. You'll see a shiny area here. What I did was I just took some standard tape and laid some strips of tape here. So I'm going to actually mix my epoxy right here and get my epoxy slathered on. Okay. We've got a stir stick and little applicator squeegee stick that I just keep snipping off the end after I let the epoxy cure to it. We've got a Wham Bam mat that's going to protect me from getting anything on my table, hopefully. We got our gloves. We've got a Sharpie marker because we are going to mark some areas around here so we don't wind up putting epoxy where it's not really needed. And then we've got some Vaseline. I told my wife, I was like, I need some Vaseline. We were looking today. She couldn't find any. So she just went to the store, right? And she comes back with a large tub of Vaseline. I'm like, what did you expect me to be doing here? Like, I need about a dozen screws here. So I'm going to kind of dollop some of this on something so that we can coat the screws in it and have our screws ready to go. What we're going to need to do is take some screws. These are 12mm screws. I could probably get away with some shorter ones. And I've got the screws and our nuts here so that we can immediately go through and start setting up some screws and nuts on here. And my plan is going to be mark on this one slather up on this side, put a couple of screws in the corner. That way I can get the top on, push it down, and put some screws in the nuts on the four corners. And then we'll go through and add some additional screws and nuts through here. You can see, right? Nice and shiny, very reflective. Not so shiny. I did hit the affected areas with some sandpaper and got this all scratched up. I did go through on the slots right here for our belt pass. Actually, I only did one side of the belt pass. That was good, Luke. So I probably should have done this with a respirator, but we need to do some prep work here. So let me switch over to this one here. Turn the short one. Says me. Okay, there we go. Apparently I have it called mobile and it's not, it's overhead. So what we need to do is on these belt channels, we need to round over those edges. We're gonna have to use a file to do that. And this is the half round file that I'm using. So we've got to round over these edges because if we don't, then this carbon fiber will tear up the belts because these are the actual belt loops. So your belts are going to come through here and they get tied down and secured. So we need to make sure that the corners here are, that we file them down and ease them a little bit so that we don't stand the chance of tearing our belts. And honestly, on the one side that I'm working on right now, you might be able to see where I got some decent little long gouges on it. That's perfectly fine. That's just going to help with the adhesion. When I flip it around to the other side, that's when I need to start being a little more careful. I mean, it's under the bed, so you're not going to see it, but I mean, why make it ugly if it doesn't need to be? Carbon fiber's a nice look. So why make it an issue if it doesn't need to be? And I should really be wearing a respirator and probably some other gloves and PPE right now because we're getting this nice fine dust. This nice fine dust has carbon particles in it. And that carbon, if you inhale it and it gets in your lungs, is very sharp and it's just going to tear up your lungs. So probably not a good idea to be doing this without wearing gloves because it will get caught in your skin, which is a large organ. And it will also become airborne and then you suck it in. Also, probably not a good thing. We're going to grab a towel. We're going to get some alcohol on that. And we're going to wipe these down again. We want these to be nice and clean and without a lot of finger oils. And see, that's what happens with these edges. They're, as you're going over the top, you're fine. But as soon as you catch one of these edges of this CNC material, it does tear it up fairly quickly. You think your 4 Max has good cooling? Do you now? Okay. I'm gonna I'm gonna be able to grab it by this outer edge because these kind of outrunners and these very outer edges are not going to get bonded, so I can kind of grab this and move it around like that. Now this piece I do need to be extremely careful for the time being. I'm going to go ahead and get my gloves on so that I don't make a mess of things or get finger oils everywhere. Because let's be honest, we're going to be playing with screws, bolts, and Vaseline, so we're going to make a mess of things. I'm going to take my mouse and scoot it out of the way, but what we're going to do is we just took the steps. Let me hide this again. We just took the steps to round over these edges, just chamfer them a little bit to save our belts. We're going to be using some epoxy. I got the JB Weld high heat epoxy. I went ahead and bought some new epoxy just to make sure that I got it. Instructions: clean, repair area of dirt, grease, oil, paint, rust, etc. Remove the replaceable cap. Press down on the plunger to squeeze equal amounts onto a disposable surface. Mix. Apply. Dry. If left at room temperature, product dries in an hour and cures in 24 hours. Apply heat to accelerate the cure. So if you apply heat at 250 degrees Fahrenheit, it'll cure fully within an hour of starting to apply heat. We're not going to apply heat. We're going to get the bond going. We're going to try and clean up any ooze that comes out. We're going to get our screws going. And we're also going to add some clamps to make sure that we've got a good bond. And then we're going to set it aside and move on to other things. Hey, Reverend, how's it going? How are you doing, my friend? So the one thing that we have to be careful of, and there is a caution here, is to make sure the carriage plates are oriented in the right direction before you glue them together. What we need is this tab lines up with the larger single rectangular opening. So let me bring up the overhead. So this little tab here is going to line up with this opening, not this staggered opening, because this has two M3 holes that are going to line up with these M3 holes right here. And this is the surface that we had scratched up. This is a surface that we scratched up. So I'm just laying it over like that. We've got our JB Weld. We'll go ahead and get this out of its package. And then we'll do another little prep process to get ourselves ready to go. Now, once again, I put some tape down there. The way that it tells you, again, there's a little stir stick, popsicle stick. But not sure if you can see that, if it'll show up. But it says, yeah, it's not going to. But it says mixing tray. So it basically gives you a little mixing tray that, you can use this as a mixing tray. Long story short. The end here is replaceable. You'll just twist it off, squirt some in. I normally either pull some back or just wipe it off real fast, twist the cap back on. So we'll have that. We might actually mix it right in here rather than doing this. And then maybe we'll glob some of the Vaseline over here so we can dip screws in. Now what we want to do, and it might tell us here, clean the mating surfaces very well using isopropyl alcohol. You saw that I did that. Prepare a couple of screws, washer, clamps, Vaseline. We'll have all that stuff there. Place the carriages over each other and trace the overlapping areas with a pen or marker. So that's going to be the interesting piece. So as you can see, there's different cutouts here than here. So what I'm going to do is I'm going to lay this on top, kind of line up those screw holes. And I'm going to take my Sharpie and I'm just going to make some marks here. Okay. Now, I'm going to take this whole assembly, flip it over, and do the same thing over here. Things lined up. And these will kind of be like no-go areas for the epoxy. Because we want enough epoxy to bind it together, but it does us no good to put epoxy where two mating surfaces won't touch. All that does is waste the epoxy and add more weight to things than what's needed. So what we're left with is I'll be able to flip this up. Once again, this is going to be the base that I'm sitting things down on. This gives me now an outline on here in marker where I can slather my whatchamacallit, my epoxy, and I'm going to keep things from getting all covered up and icky that don't need to be icky. Now, I am going to need a little bit of this. There's a couple of things we can do. We can either just dip this in there and fish it out. Or what's probably going to be better off is to just put a dollop down here. But what we're going to want is we're going to want Vaseline that comes all the way down to the head, because if it gets pushed through the bottom head here, it will then get on the screw head and we'll go to try and remove the screw and it ain't going to come off. So that will then be an issue. And hey, Eagle, how's it going? Welcome, welcome. So I'm just going to stick a couple, three of these down in here and then we'll fish them back out. And these are going to be the four corner posts of the bed. And once we get these four corners in, we'll be able to go through and add additional screws once we get everything locked in, because this is going to help provide our initial alignment. And then we'll be able to go through and add some more screws through the center. Okay, so we'll leave that out. We'll leave this here. I'm going to move this over here so it's out of the way. And we're going to start with decapping this. And I'm not going to need a whole lot, but we do want to try and get it out in an even press. Like that is way more than I actually need, but So be it. Like that. That locks back up. Nice and clean. Set that off to the side. I'm going to use the little stick here and just work on combining these two together. We want to make sure to constantly scrape everything back in towards the center. Now, I was looking at this, and this is a 1 hour dry time. So, like normally I would be a little bit worried and be a little more frantic about trying to get this stuff going, but I can take my time to really get this mixed well. With a 1 hour dry time, we're going to have plenty of time to work with here. And we'll be able to make sure that we get a decent smear of material without going like super crazy thick. Now, I probably will not be looking up as I'm trying to get this laid on here. So if I don't chat for a while, please bear with me. Like I said, you don't need to scoop it on there because it will make a, we are going to tighten this up together. It is going to squish out on the sides some. So if you get if you ice it like a cake, you're going to have plenty of squish out that you're going to have to clean up, which is another reason why I've got my Wham Bam mat here being silicone. I can just let it dry and I should be able to pull this straight off. I may have done like an ideal amount of epoxy there. Okay, I think that is sufficiently slathered. Once again, we want our tab facing the larger cutout here. And we've got our screws there. I know I can grab it like that. So we're just going to try and line those screws up. One side, then the other. That. Now this is where it might get interesting because we probably should get these with a little bit of Vaseline on them as well. Once again, the Vaseline can clean up the, if it adheres to the epoxy, you're not getting it back off without drilling things all the way out. And that's, having done that, that's not as much fun as it sounds. So be mindful. That one in. And Maker Milo showed his, and it was funny because it was like, I think the well, the picture that's in here, you'll see like this is how he's got it when it's all clamped up, and you see um the Vaseline on there, right? But I like how he did it because, or how he did the instructions here. And I think this is Maker Milo. This might not have been Maker Milo. This might have actually been the pictures from the gentleman that designed this printer. But I'll show you in half a second here. Look how nice and pretty that is. Because that was put together without any, I mean, it's got the 4 screws in it, but it's just 4 screws through the plate. That was before they added any, whatchamacallit to it. That was before they added any epoxy to it. What I'm going to do is I'm going to set this on its side. I'm going to grab the back and I'm just going to tighten this down. I'm going to do that at all 4 corners. Not going to completely ugga-dugga it, but I am going to apply a little bit of tension. And with those 4 done, now we can go through and do a few more. Enhancing the manual. Yep. All they're doing is making it easier to see what they're working on. Can't fault them for that. Cannot fault them for that. Oy. Like I said, you want to make sure that you get some petroleum jelly all the way up to the head of the bolts, so that they are properly gooped up and aligned. That one's not seeming to align. Why are you not aligned? Ever so slightly. There we go. You might have to do a little bit of massaging there. And some of these they just might not go into because either minor misalignments when they were um, when they because they're laser cut at different times, right? They're laser cut or CNC cut, so the holes might be slightly different. And I didn't even think about trying to go through and doing a 3 millimeter bore out of these. Once again, I'm using these to try and help with alignment, but I will be going through and doing some clamps on here as well. You go there. You go there. There's some more of these washers or washers, nuts. Ah, my foot's doing okay, Eagle. My foot's doing okay. I was able to stay off of it most of the day because I stayed home. Our standard leadership huddle was canceled, so I stayed home today. I'm going to go into the office tomorrow, at least for an initial meeting, and then I got to head over to going away lunch for one of my guys. His final day was actually last Friday. So, and I say one of my guys, he was one of my guys until February when he got moved over to another shop. And that shop did not do any type of going away for him. So I'm going to take him out to lunch. Okay. We're going to need to wipe down our implements to get all the Vaseline off of them, or at least attempt to. And we'll have to, I guess we don't have to, but I'm going to try and clean these up a little bit once I get these tightened down. You don't have to go into every single hole on here. We're just going to go into several holes to tighten this down. And then, like I said, we'll add some, darn it. We'll add some clamps to this as well. Make sure we have some good pressure all the way across it. Basically using the screws more for alignment than anything else. should be easy enough to wipe off any excess petroleum jelly. And we tried really hard to not get a lot of excess epoxy out. So we're good there. Trying to think what I'm going to do here. Set that there. We're going to put that there. We're going to find a place to set this so that it can dry for an hour. And who knows, maybe we'll take and we'll set that right there on top of that side, and we'll try and work over on this side. Or I don't think that's going to work either. So, because we're going to need this whole table. I'm going to move this over onto the floor where it'll be out of the way. And when we're done with our stuff tonight, I'll move it back up here onto the table so it can fully cure overnight and all day tomorrow. Let's not sit that next to an exhaust fan. Okay. The good news is I have plenty of these screws, so I might just take, when I take those out, I might just throw them away because they're all goopy. I think I'm going to wipe this down just to make sure we don't have any crud on here. Always good to have shop towels, paper towels. I think the blue shop towels would actually be better. We got a little bit of super glue on here still, so I'm going to need to come up here with a razor blade and scratch that off a little bit. Okay, so, oh, changed camera. My bad. My bad. So we've cleaned this area off now. I did take my gloves off, but we've got the thing sitting on the floor right over here off the bench. I don't know if I can get this to, we'll see if that picks it up. Yeah, this kind of sitting there on the floor right underneath the tripod where I won't step on it and make a big mess, but it's sitting right down there. I left it on the silicone and actually on the tape on the silicone. The epoxy won't adhere to either one. So that'll be good. And now what's up? We're going to keep moving on. We'll get the rest of the y-axis done. But this is the bonding of these two. What it shows right here is, oh, I'm not showing you what I'm looking at. Gotcha. Go there, come here, we say properties. Okay. So what we just did was we bonded two of the layers together. Where you see the 4 screws coming through, that's going to the solid build plate that's underneath that would have the polyamide heater on it. So we're good with that for now. Once we were going to put clamps on it, weren't we? Let me go do that real fast. We'll add some clamps around the 4 corners to really kind of hold that in or hold that down, especially in certain places. Where we might not have had screws at. There we go. See, almost forgot about the clamps. It's snowing at your house. Awesome. I am so glad that you guys are getting snow. And I'm not. Let's see. This was the E-box. I think we had. Now this was assembling the E-box and then doing some wiring. Um, I did realize that the three of the parts that I was sitting there like, I don't know where this goes. I don't know where this goes. Yeah, these parts here actually were to hold the Wagos. I just VHB'd them directly to the electronics, so no harm, no foul. I also had done some looking, and there was no 24-volt power supply in my kit. So I have reached out to Fabrico, and I also need to reach out to FISEC because they ship the printer directly to me. I don't know if they had taken out Mornsun and just didn't put it in. I don't know, but we'll see if I can get them to replace me. If not, like I said, I had a couple on the bench, so I'm still good. I can keep going. So this would be the piece. I've got the one half installed. The other half I will install once I get the last wire. There should be one set of wires that comes out for the power still that either I haven't seen or I just didn't notice. So let me take a quick look real fast. Hey, this looks like the power. So this is going to be the power that will hit the E-box, which means this side, I'm sorry, this heats, this will hit the breakout box, the breakout board. So these will be the ones that go onto the main electronics box. So we can add this in. And once we add this to the electronics box here, then we can completely close up this electronics box. I say that, and then I'm going to take that back. We still haven't connected the, we have not connected the Raspberry Pi to the Spider, and that'll need to be done as well. So we'll do these last couple of connections, and then we'll be ready to get a move on and start working on the brain fart that I'm having. We'll work on the X-axis and the Y belts. So we're going to look at our things. We've got heater HE plus and heater bed plus. So of course this is going to be our heater 1 and our bed out. So this is not using an SSR. I have seen some of the build pictures that show an SSR, but it's actually in that scenario that they were showing, the SSR was being controlled by the Raspberry Pi, and you were bringing 5-volt wall wart into the Raspberry Pi, and then another, still using the standard connector to run the 24 and 48-volt power supplies. So basically what you were doing was you were using the Raspberry Pi and the SSR to trigger the power in to both of the power supplies. So basically you could shut everything down and just leave the Raspberry Pi and use it to turn the heater or the printer on. Okay, so HE, so this is the hot end positive. That's on the right side here. Let me, for now, move these out of the way. HE positive. Go there. A little forward pressure as we screw this down. There's HE positive. HE negative. HE negative, HE positive. Come on. We'll have HB negative and HB positive. And we'll probably do the positive first because that will be your one to get to here. HB negative. And then this next one is a fork connector that says ground. This is actually designed to go to the one of the ground lugs or the V negative on your power supply. That might be easier, but that might also have been one of the erratas. So let's take a look down here at the issues. We did the Z separ motors already. We did those swaps. So this is the one it was talking about. It's talking about taking the fork connector here and cutting it off. So unreliable hot end thermistor reading. The PWM value of the hot end heater is seen to pulsate between 0 and 100%, which has been traced back to the PT1000 thermistor ground supply. It is due to a mismatch in ground levels between the PSU and the main board. To fix this issue can be solved by sourcing ground from a different place closer to the MCU point of reference. So it says to cut this fork connector and solder in a splice of 22 or 24 gauge extension, terminate with the JST XH Krempen connector, and that gets plugged in to a ground I'll say right here, which is going to be hard for you guys to see. So basically we would make an extension for this, bring it around and pop it into a ground over here. So let me go ahead and make that, and then we can do the cut and add this to the ground over here. You experience other issues in regard to maintaining the hot end heating power at high values, then it's recommended to install the auxiliary fan aero diverter. That would be something that we haven't done yet, or we haven't built yet, so we can add that. So other than weather, how's everybody doing this Thursday? Week's almost over, and next week is a short week for everybody. So hope everybody has some plans for next week. So we're going to need some 22 or 24 gauge cable. And honestly, I'm probably going to use 20 gauge. I know they say 24 or 22 to 24. I'm probably going to use 20 gauge just because that cable that they're already using looks to be pretty hefty in its own right. So I don't want to drop it down that far. That 20 gauge is red. $18 gauge, 20 gauge is red. I don't want to use red 20 gauge for ground. Oy. So I'll go ahead and put a JST on this side, route it around, figure out how far we need to go, and then we'll do the soldering there. Like I said, this is a bit thicker wire, so I don't want to like drop it down drastically. But I also know I don't want to do anything too big over there. 24 gauge FEP wire should be fine. Probably going to have to use my own JSTs here. No big deal. That is a 2-pin. Grab a 2-pin and a crimp connector. And our tools. So once again, I hope everybody's doing good tonight. Also hope that the stream is staying good. Yep, no frames lost, so that's good. I know I've got, like I said, another semi big day where I have to go into work and deal with some things, but it's really go do lunch and then come home again, run some things to the ground, and then enjoy the weekend. Saturday, we can spend either continuing on the LH Stinger build, or we can switch over to rebelting the V24. Probably say continue with the Stinger build because I'm kind of excited to see it done now. So I think we'll continue on with this. What I'm going to do is pop this into the right spot. You put it in the right orientation. I'm going to go there, add it, bring it down around here. I'm just trying to see about where this would go. That looks to be about a decent amount. So we need to strip this end, cut and strip the other wire, And we'll use one of our butt connectors to solder these together. I say butt connectors, and butt connector is not the appropriate term, but I'll show you what I mean when I say that. Oh, it's just Polymaker going live. I was like, what is this thing over here like dinging incessantly for? Get that done. Now, the question is, with this being 18 gauge, might have to 18 gauge and 20 gauge. What we're marrying up here. There's my red ones versus the white ones I would normally use. I can open this up without tossing it everywhere. What we're going to do is we're going to bring these cables in, make sure that the wires are crossing, words on stream. Pull this back out. Might be easier to do this down here with a stand to hold our wires. Use our OmniFixos to hold our wires. This will allow us to keep our wires in line and right at the solder joint. Or essentially at the solder. No potential. It's got to be at the solder joint. Not out at the solder joint, then it's there we go. So the connectors that I'm using are soldered butt connectors. And what we'll do is this center ring here is solder. So you bring your wires in from each side. Depending on your wires, you could actually twist them together and slide this so that the wires are right here where the centerpiece is. You'll heat this centerpiece up. It'll melt the solder and solder the wires together. And then you shrink down both sides. And this red piece here is glue that's going to hold it in place as well. You're going to get a really good strong connection here. And like I said, you can, and I have seen them say, strip back these wires and actually twist them together. I have not done that to date. Probably do that on this one. I'll just have to strip it back some more. You're not. Strip that back a little bit more. We'll strip this one back a little bit more. We'll get a little bit of twist on the wires there. Then we'll set up to solder these together. God. Step wire, I swear. Peeled nicely off of one side, and then the other side, it didn't cut all the way through, and then it just stretches. Okay. That we'll take these two wires and twist them together some. Twist them together some. That. This back over the top. And getting um the solder joint lined up with the wires. We'll grab our heat gun and apply heat, and then that's going to solder this together for us. And this will be the last part of our electronics box done. I use this. Okay, we'll let that sit and cool. We'll let this wire sit and cool. That joint will be kind of malleable for a little bit, so let it sit and kind of solidify up some. It'll be kind of tacky. You want that to solidify up. Ugh. That away later. We'll do a strength test. Give it a good pull. Good. See if we can get our ground cable marker up here. Go. Add it into our wiring. A little bit longer than we needed it, but that's okay. And side over here, longer side over here. this one around so it's the right side up. Put this away, and then we can make sure that all of our cables are coming out nicely. And we're going to put a zip tie around these. Now we'll use work. So in essence, what we're doing here is we're just zip tying these cables to the backside half. Makes sense, of the box. Go. And the goal here is, like I said, just to provide strain relief to these wires that are coming out. And keeping them right nice and solid. Now, crap, does actually go around both. I will have to cut that back out. On this piece, there is a piece that slides in and gets attached right here. It's basically what allows you to pull this out and play with your cables. It's really just an alignment piece that helps you slide this piece in and out. Maybe I'll super glue it. Maybe I won't. First off, let me see if I can find it. There, those are there. I think it is this piece right here. So we're going just like that. It is, once again, keyed to go into that slot. It'd just be something that we super glue together. And then it'll allow a better connection there. Let's grab our super glue. We'll get that super glued. Set it off to the side so it can do its thing, because we know our super glue takes a little bit to do its thing. Because we've got the medium super glue, which takes a little bit more. And apparently it skimmed over on me again. Hey, Shrimp Father, how's it going? We got the bed kind of done up, and it is drying. It's going to dry for the next 24 hours. It should be pretty good by the end of the stream as far as the initial dry, but it takes 24 hours to fully cure. So we're going to kind of let it sit there and get fully cured up before we do anything with it. We're gluing these two pieces together, and this is going to be the second half of our cable support here at the end of the box. So we'll get this held together for a short bit until it does its initial set, and then we can add the top of the box still. Probably do that one-handed while we're holding this. This is going to go in there just like this. This is going to use some more M3x8s, I'm pretty sure. Actually, those are flathead screws. They're not the M3x8 socket heads. M3x8 or M3x10? 3x8. Hold those 4 top corners in. So we got some of those. So how's your night going, Shrimp Father? We're doing good. We've got, like I said, we got the bed set up. It's going good. I had opened this earlier, took the Raspberry Pi out and put the heat sinks on it, and then promptly got it screwed back down there and forgot to put the SD card in it that I flashed last night with the Raspberry Pi. Excuse me, not the Raspberry Pi, with Mainsail OS. So I took the back plate off and stuck that in there. And if for whatever reason we need to get back in there, we just take the 4 screws off the back plate when we can pull that out. Easy enough, easy peasy. Okay, so those are done. We still need to install this, which should be, it is not set yet. So we'll keep holding it. I have no idea why this super glue. I mean, I know it's medium, but good God. Taking forever to set up these days. We're just going to have to let that sit there for a while. And I want to add that to this side here. And then once we get that done, the lid can go on. The front lid, we still need to plug in our fans. So we have the 2 EF fans. Where did those go? Not that. We need the wiring diagram. Where's the assembly diagram or the assembly guide? That's what we just did. Wiring diagram is up here. Where does the 2 case fan? E-box fans, EF. They go to fan 4 and 5. Fan doesn't go on this one. It goes in the next 2 here. It goes to either side, like the next 2 in line here. So one there. And one. Those are in the right orientation. And this will lay right there. We're going to use some filament as the hinge. And then this will be able to lift up just with the magnets. Once again, we'll slide this on and add this in a little bit. after we let this sit up for a while longer. So we just need 2 pieces of filament there. Where, oh where am I tonight? This is LVO black. Let me go ahead and pull the Cookie CAD filament out. This is once again the Dark Magic CAD filament. And what we're going to do is I'm literally just going to take this filament and slide it from one side to the other, hopefully. Of course, that's not going to work very well. Now, I wonder if this has a hole that's smaller. It just might be that I need to clean up this end some. Might just be this end. Maybe a tight fit. It may be one of those things where we get this in and it ain't coming back out. Nope, not going to go in. So we may need to, quote unquote, relieve that hole a bit. In order to get that on there. Just slightly out of round. So, oh, what do we got? What do we got? What do we got? We're going to have to use a drill because my reamers that I just dropped everywhere only go down to a 3. That was lovely. 3. 4. 5. 6. 7. All right, there's those. Yeah, it's so in dealing with these in the past, Chewy, I've always been a little suspect, I'll say, about the remote box stuff. But in looking at this one and the way it's designed, I think it's going to work out really, really well. And I might have to do this by hand because I'm not sure if this goes into my drill or not. Well, maybe. Got through the one side, but I think what I'm going to do is take this off so that I can get to it easier. Yeah, I was a little worried about having the external box for a while, and then the more I think about it, it works really well, especially if you're doing an enclosure, because you don't want your electronics in the heat of the enclosure if you can handle or if you can prevent it. So so my choices are a 1.5 or a 2. So I'm using a 2 millimeter here, um, which is going to wind up being a little bit too big, but I think that's preferable to a little bit too small, and just trying to wiggle it and then get something that's misshapen and still an issue. So and once again, we also have to do this side. I have to take those off as well. But yeah, this particular box build is pretty neat. I think it does this type of design a real good justice to have this D-box out here. And like I said, they're going to have, or there is a a draft. I say draft, a beta optional enclosure for this. So they have started thinking about that down the road, which will allow you to do ABS and things like that. Um, I don't know if it's really going to be needed. I've got a lot of other machines that I can use to print ABS on, so I really don't need this one to be um, enclosed and printing ABS and all that good stuff. So we'll have to see how that plays out. Uh-oh. Ruh-roh, George. I think this one, I think one of these is spinning. Nope, it is spinning. So can I get this to an angle where I can? Okay. There, here. This one off and open it up, and then we can put our hinge material in, and by then our other piece should hopefully be done so that we can fully close this up and move on knowing that there's nothing left to do to this. Now, is anybody doing any printing for Christmas? I haven't started yet, but apparently Mrs. Dragon had hung up a one of the Flexi Factory skeleton astronauts, or maybe if the full up alien, I can't remember which one she said, at her mom's, and apparently everybody liked it. And so she's asked if I can provide something to her for Christmas to hang up on her door or set on her little they've got like little tables right outside their doors. So all we're going to do is we're going to bring it to the one side and then we'll snip it off at the other end. I may go just a little bit longer. Same thing over on this side. Now, because of what we had to do to open these up, this filament is now pretty darn loose. As it, because it's of course 1.75 millimeter filament and a 2 millimeter hole now. Why is this not lining up? Being in one direction, not the other. So we'll go ahead and put this back in here now. $5 bill and a hearty handshake. Hey, do what you can. Do what you can. That goes there. Make sure that this stays shut. That goes on top. That tape goes there. That goes back there. Leave this out for a little bit longer because we don't know if we're going to need it again. Okay, and they feel relatively bonded together. So what I'm going to do, we're going to take this piece. This side goes on the inside. Just slide that on there. We'll have to put 2 screws here, and then we can do our zip tie. These will be M3x8 socket head screws. And the electronics box will now be done. Now, I'm not sure what this hole here is for, because it's not in the CAD, or at least not in the CAD that I was seeing. So we look at the eBox CAD, there's no hole here. I guess that's the opposite. Yeah, there is a hole there. I have no idea what for. Just we'll live with the hole there. I don't know if it's aid in sucking air in or blowing air out, or who knows? Don't know. I do know that there is a different panel on one of these that would allow you to orientate the Raspberry Pi and gain access to the Raspberry Pi um, ports. I don't think I'm going to need to. If I feel like I need to somewhere down the road, we'll go ahead and work to get access. But until then, I think we're good. Just looking to see if I've got zip ties in the kit. I thought there were. Not sure what I did with them. So maybe, oh, there they are. Small thing of zip ties. Grab one of these. And once again, we're going to loop around and hopefully it follows through and out the other side. Did not. No idea how that's meant to go in there and still come through in the appropriate spot. Looks like there is a cutout that it rides in this piece. Just not sure how to get it to definitely angle back out the other hole. Looked like there was a spot it was right. Not. There we go. First you don't succeed, try tweezers. We'll just pull that tight. Once again, all we're doing is providing some strain relief support right here with this zip tie. Trim that off. And voila. One electronics box fully completed and closed. I really do like this color. This is a beautiful color. This is the Ambrosia Midnight Meteorite, I think. So, very, very nice color. This can just sit off to the side. Once again, the Raspberry Pi in there has been flashed. I did flash that, so that is good to go. Going to close that. Didn't need it anymore. Let's come back to the assembly guide. Take this back down to something more reasonable. And we're going to scroll down here a ways. Drive and realize that I'm not in the right window. Yeah, the Breakout Electronics box is really nice. Dr. Stab Wounds. It is really nice. It is a good choice. I had started to create one that was a mod for the TiVo Tarantula. I'm going to have to get back to that at some point. We really need to revive the Tevo Tarantula. I've got a few things that I want to use on that build or that rebuild. So the Y drive, we've already got this built. We need to do the bed carriage, which is sitting over there drying right now. So we'll do that on Saturday. We'll add the bed carriage. We've got these sanded flush, and we'll have to get our belts in there, and at the end of it, we'll wind up with something along the lines of this, with the belt plates or the belts done up. This is a printed carriage. Don't know why, because I'm pretty sure we don't use a printed carriage on here. At least I haven't seen a printed carriage in the kit, so we'll do the Y-frame mounting. It looks like we do have a block that we will use. And get this mounted up. In fact, we probably could mount this even without the bed on there. We should be able to mount this and then do the bed rail stuff. Maybe we'll do that next. We'll go ahead and do that. So let me grab the two parts. So what we've got is our upper rail here. This might be easier if I switch the camera view. Yeah. So this is our upright with our two Z motors. This is the back side of the printer. This would be the front side. The one thing that I did not do yet was put these on. They did say that that this is an issue, that this was too hard of a material, and that we should really be using a less dense material for these parts of the yes, footrest or whatever you want to call it. I'm still going to go ahead and use those. It is what it is. I don't think there's a huge need. So it's this hard foam. Actually, that's just a hard rubber. Not even real foam. So all you have to do, these are going to lay in there and go right around the big M8 screws there and just get pushed on. We just never did this before, so we'll go ahead and do this part now. There's the one side. I might actually, when I do the rebuild of the Tevo Tarantula, I might actually use the same electronics box design. I'm just going to lean on, put a little bit of pressure on those to let the adhesive set in. All right, that feels good. Put that out of the way. We'll grab our Y-axis. Once again, here's our Y-axis. Get some, I don't know how that fuzzy got in there, but there's a fuzzy in there. Now, we don't have a front or back, or let me rephrase that. I didn't think we had a front or back. We do have a front or back. This is the front. This is the back. How do we know that? Well, we've got bump stops on the front here. We have one on the back, and then there's one missing. This is for the Y end stop. So we still need to get that installed. But what I'm going to do right now is flip it over on the table. We've got 4 T-nuts in here. So what we're going to do is we're going to go ahead and get our other 4 corner brackets. And it looks like the on our corner brackets, we have a flat side and a rounded side. So according to this, the flat sides are going down onto this side. So that is correct. I'm going to go ahead and, again, this is a back side. I'm going to get these started. Let's get it started. And with the vibrations that we get in here, I'm putting Loctite on all of these. For those of you that haven't been following along, I'll pull up the video here in a second and show you why I'm putting Loctite on T-nuts. And I'm pulling this all the way to the back, up against the printed part, and locking it down, because looking at this guide, we'll have a gap here. Oh, I'm sorry. I'm supposed to leave a 1 millimeter gap. The hell do I leave a 1 millimeter gap? We're going to leave a 1 millimeter gap or something thereabouts. We're going to take a zip tie. We're going to use the width of a zip tie. So we're just going to set that zip tie in there. Put this right up against the zip tie. And then we'll tighten that down. So we're using the width of a zip, or the thickness of a zip tie, to get us a gap right there. And these are the 16 by 4 flatheads, or M6 by 14 flathead screws. There's one. We'll get another one of these out. Flip over here to the overhead view again. Put a Loctite on these threads. Get it lined up and started on our nut. Scoot it down. I'm just going to apply some backward pressure so it gets nice and tight up against that zip tie. So that sets the rears and gives us a slight gap between the metal part and the printed part. So we're not, I don't know why they're concerned about translating, because this is attached to this, which is attached to this, but I don't know. I just follow the instructions some of the time. So some of these bags I keep, some I don't. These are small enough that, you know, if I come across a need for them, then I will keep them. If not, I normally toss them in the garbage, and I'll keep the larger ones just because they tend to be a little more useful for collecting parts and stuff. These ones here, I'm going to leave them so that they can still move around. Okay. And on our frame here, we do have some captive T-nuts in here on the front and the back that we will be using to secure these. Of course, what we'll do is we'll do the rear first because these are locked in and we can get these put in. And why does that look like it's not parallel and straight? It's not. We'll get these locked in on the back and then we'll line up the front and get those locked in. Easy peasy lemon squeezy. Ah, this one has a little nub on it. So we'll have to definitely make sure that we're straight when we get in here. We're going to take this piece and basically flip it over, set it in there. We'll need to line up our screw holes and get some screws started in there. And looking at it with how tight this is going to be to get in here with our screws, I'm either going to need to use a whatchamacallit, ball end wrench, use our ball end driver, or something else to come in at an angle. So we'll just have to be careful with that. We're going to have to look and see which screws that we use here. M6 by 14 countersunk screws to that. Great. Those are those. These. M6 by 14. Countersunk on both sides? Yeah, I guess they are. Okay, so we'll grab the M6 by 14s again. Might have an issue. We'll see. And I'll show you what I mean here in a minute. Just with getting access to the heads of these, we may have to play some shenanigans. We'll see though. Be able to get in there. They're doing good, Eagle. I haven't talked to them today, but I am sure that they are still doing good. We'll call them after stream. We'll get a little bit of Loctite on here, and we'll have to try and fish this through. Fish that through. Go ahead and get the second one set up and fish through as well. And then what we're going to need to do is I just want to get the nuts lined up. And if I can get the nuts lined up close, and I can get these started, Then I'll be able to come in and do the side to side movement. You. All right, that side got lined up. I'm going to turn this around to make sure I can get this other side lined up. Opposite what I wanted. Okay, so I've got both of these nuts started. So what we're going to do next is find our distance. And we've got a jig for that. We'll set that over there. We'll grab our printed parts and we'll find that jig. It's already out here. So we've got this printed jig here. Okay. Switch over to the other screen real fast. Okay. And this jig shows Z to Y. So that's what we're going to use to set our distance from here over to here. Now, when we go to do that, back to our assembly, don't need the E-box anymore. That. On the assembly manual here, as you can see, this is going from where the mount is all the way over. Now what I can't, I'm assuming that this is the edge that it's going up against. So we set that in there like that. Keep the key going. And then we'll scoot this over. Until it lines up. So it's lined up there. I'm going to tighten this side, or at least snug it up. You kind of saw this move. We'll snug this side up. See it move some more. So snugging these up should, in theory, center these because they're countersunk screws. Take our square blocks. And do some checking. Primarily, I'm going to use the rail. I'm going to go flat up against the front here, slide it up against our rail, and see if we've got any side-to-side movement, which we don't, which tells me this is now perpendicular to this. Same thing over here. So I just verified that we're nice and square. So now that we've got those two sides done, what I'm going to do is set this up on its edge. Well, that's not going to work either because then I'm going to, oh, maybe. We should be able to make that work. I've got a plan, I think. I'm going to have to use my ball end. We'll get that started. We're going to need to bring this up. We're going to kind of do the same thing we did before. You use this to kind of hold things in place here. All I want to do is line this up and get it started. That will help snug things up. Do the same thing on the other one. Get our Loctite going. Slide that up. Get it lined up. Start getting this side snugged up. Going to hold this underneath. Going to make sure that this stays in line here. So now, just like that, my y-axis is lined up. We've got that little 1 inch or that 1 millimeter gap back here. We've got our y-axis now lined up in there. We'll still need to install our bed at some point, but we'll do that Saturday once we have the bed frame dry. Once again, this is the back side because there's an opening right here for the Y-end stop that I haven't installed yet. So the y-axis is now installed. Here the y-axis is exactly perpendicular 90 degrees to the rest of the frame. The alignment directly affects the XY. All right, and you see this, right, where it's rocking? Because I've got my feet all the way in. So we can solve that problem by unscrewing our feet some. And we've got M5 nuts down here. I'm probably going to need to find or go get my M5 wrench so that I can loosen these some. Don't know. That's not gonna. Wonder. Yeah, because we're using the 5 millimeter nut as a jam nut basically. I don't know. I'll have to figure that out. We'll be a little wonky for a bit. Because that's not going to be, or that's going to be too thick to get in there and try and really adjust these appropriately. So we'll work on adjusting that front to back tilt. The last thing we want is for this to be moving back and forth and this sitting here doing this, rocking back and forth. That would be bad. We just need to shim these feet out some. Yeah, so this is how that carriage will look. We'll get there eventually. The bed, once this carriage dries and we get everything on there, we'll add the bed. Do that portion. So we'll come back to that. X-belt installation. Following steps are done off the printer. Okay. Hold the belt and roughly measure or mark the length of the loop that would go inside the tensioner belt loop around the screw depicted in the image below. We'll let you know when it's inserted all the way through. Okay. Push it in using pliers. If it doesn't go in easily, be careful not to damage the belt. When you think you're done, you can insert a hex key into that hole and pull the belt to check if it's looped all the way into the cavity. Then we'll insert the retaining screw into the plastic part, and that's going to leave the captive or the belt there. Set this down real fast, out of the way as much as possible, because we know me, I will trip over things if they're available to trip over. I'm just looking to see what belt I have. Those two belts, and then I'm going to need printed parts. I think this would be the in here. So this is the e-box. This is the fan. E-box, e-box, fans, standoffs for the e-box. You know, why don't we build that stuff and then we'll come back to the Xbox or the X Gantrian. Nah, we'll do the X. We'll keep going the way we were going to go. We'll do the X. Those parts should be in here. So there's not a lot of these parts left in here. Let's see what we got. We've got that's tool head. These I think are the Z. So these are belt type things. This I believe goes to the bed. So that's an end stop. Bed alignment piece, that's a tensioner, no. Not in there. This is the fan stuff. Am I missing anything else? These are X-belt parts. Tool head. So this is definitely going to get a heat set insert, and these are going to be used for belt tensioning. The switch back to this view. These are going to be used for belt tensioning. These were spacers and alignment jigs, so they'll go back into the tool bag. These were spacer pieces that we're not going to need anymore. These are cable tie down stuff. In stop, in stop, in stop. This piece. Doesn't look like it. This looks like an in-stop piece as well. There would be 3 end stops, X, Y, and Z. Belt, belt. All right, I'm confused. Not sure if I'm missing a part or... Nope, X and X idler. I wonder if I'm missing a part. Chamfer, chamfer. Oh, no. This is that part. Chamfer, chamfer. Chamfer, chamfer. Hole, hole. Spot for a thing. Belt's going to come down. Oh. Belt's going to come down at an angle through here. The other belt is going to come, or the other end of the belt comes this way. And will get pulled through with the screw from this side. So this is the piece. It was just weird looking. Okay. Doesn't say. Doesn't say what screw to use here. So we're going to have to look. Ooh. This is the X belt. Tensioning piece. Let me model browser. Let's get rid of the frame. We want the X. Go ahead. Okay. So here's the tool head. This is the piece that we're looking at right now. Piece right here on the CAD. So this screw is going to be a M3 by 16 countersunk. Grab one of those and get those out. And this belt, assuming is the 6mm belt. So we've got, looks like 6mm belt and 9mm. The 9mm should be for the Z, I believe. And this should be the 6mm belt, partly because I don't think 9 will go down in there. So, well, crud, maybe. Where is, oh, common sense here, Luke. What size belt is it going to be? Well, I don't know. What size pulleys are we going to be? Idler, 6mm belt. Done. We're using the 6mm belt. Why? Why do I do this to myself? Right now, just so it doesn't go everywhere, I'm just going to use a small bit of it. And it gets folded over on itself. We're going to fold it over on itself a little bit here. And we're trying to see about how far it would need to go in there, knowing that it's going to do a little kind of loop around like that. And then we've got to try and shove it down in the hole. Surprisingly enough, fairly easy once you get through the, well, it was. Then I open my mouth. Hey, I'm seeing the belt. Got the belt there. Now we need to use an Allen key or our tweezers or something to open the belt up. Pull on it to make sure that we're actually in the loop there, which we are. Then we're going to take our M3x16 and go through this. And in essence, what this is doing is it's going to become a pin that locks that belt in place. That's going to prevent this belt from pulling out through this piece. Okay, so that's all the way in. It is going into plastic, so don't ugga-dugga the crap out of it. But I am going to grab this and pull, and that's going to tell me that it is definitely around that, and that when I was tightening up, it didn't compress to one side. So that's a really good connection there. Now, one thing I got to figure out is, are these magnets or are these heat sets that go in here? So let me double check that real fast. Place to put that out. CAD. And that's all we needed to do at this point on the part. But what I need to do, kind of look at this piece. Ah, yes. Screws. Quickie probe. Where is it going? This is quickie probe comes. Okay. Sorry, folks. I'm sitting here trying to understand the CAD and how this particular piece sets in there. So I think those are going to be magnets to enable clicky probe to be picked up and put down. For now, I'm just going to loop this back up because it looks like we've got this part done for now, and it's just going to sit to the side until we get a couple of other parts done. So we're just going to set that off to the side there. Back to the instructions. Insert the belt loop in that threads directly into plastic. Leave the other end free for now. We've got that. Yes, yes. Now we're going to need a few parts. So we're going to need the tooth idler, a 25 by 5 millimeter shaft, assume that it's this one. It's a round shaft, shims, 7501. Seven by 5 by 0.5. One of those. 5101. One of these. Some 2020 M5 square nuts. Pair of these. M3 hex nut. One of these. Just trying to get all the hardware out so that we can do some stuff. M5 by 10 low head. These are specific, like different head screws. Low head. One of those. M5 by 12 socket head. Those. M3 by 12 button head. One of those. Couple of M3 by 12 socket head. which I am not seeing here. So it is quite possible that I need to just grab one of those myself or something different. And M3 by 22 socket heads. Or actually, I take that back. Two M3 by 22s, two M3 by 12s are sitting there. Okay, there's all of our parts that we need for now. Insert the idler shaft into the tooth idler. Okay, idler shaft, tooth idler. Wrap the belt around it. Okay. And through the mount to the cart, attach the belt. Eh? Eh? Okay. Got the cart. One of the M5. Oh. Okay, this is the side over here. The M5 by 10 low head is coming from this side, which will be the front side. So the M5 by 10 low head, the M5 by 10 low head has the so if this is the M5 by 10 low head, it's got the smaller, thinner gem underneath it. Comes in from the front here, and we'll put one of the hex nuts on it. Okay. Then the other screw with the larger washer comes in from the back side here. We'll also get an M5 T-nut properly orientated on it. Okay, so we've got those two. Shaft here, we have to loop the belt around it. Around the tooth pulley. And which way is the belt oriented? Coming this way into this side, so it'll slide in there like that. How in the hell? Ah. So there is a hole here on this side that this shaft's going to push into. And this downward divot is where the thing goes through. So that's somewhat started. This will need to go around here. This goes that. This goes in like this. Got to push that back down in there and in place, and then get that shaft to line up and go through, which will be easier said than done. Oh, here we go. I think I got it started. Now I just need to get the shaft pushed through there. You can go ahead and make sure that that shaft's pushed all the way through, because this hole right here is a push through hole. So if you ever need to take this back out, you can push the end of that shaft back through and out the back. But what I was trying to figure out was this on the top or on the bottom? And looking at the CAD here, it goes around the bottom, and then the top side gets kind of routed into the channel of the 2020. So we've got those in there. So insert the idler shaft, thread the X belt in behind the idler, through the mount to the cart, attach the belt. Okay. Geez, seriously? So I just put the M5s in here, and I have to take them back out, because when it says attach it to the cart, what it's telling you to do is mount it um, on the left side, or excuse me, the right side of the printer. And as soon as you have to be able to access these holes to mount it, and then if these are in place, you can't mount it. So long story short, we're going to take some things, we're going to move some things around over here, not cover up our screws, but do move them out of the way, because we're going to need to bring the printer itself back up here. Ugh. And we're working on this side of the printer. This is the side that we're going to be installing on. So I've got two shorter ones, two longer ones. Looking at this, the shorter ones are going to go at the top, the longer ones are going to go in at the bottom. And let me see something here. So we do get a decent amount of thread exposed here. So once again, I am going to push it through and then get a very small amount of thread locker. And that's gonna give me the ability to thread lock at least one of these. I don't really want to run thread locker through all of them, or actually through any of the printed part, but I do want to get some thread locker to help hold these on at least in one spot. Smaller ones. or two larger ones. Do the normal Ugga Dugga in a crossing pattern. There we go. There we go. That side's on there. We now have our belt going through. And I think what we're going to be able to do is just kind of figure out what our belt length is going to be. And say trim some of the fat. I should have plenty of belt length, and if not, then I do have plenty more 6mm Gates belt, so that's not that big of a deal. Okay, so the one side's somewhat done. I need to put the M5 hardware back in. I'm still missing an M3 hardware piece. It called out for a button head screw that I didn't see used anywhere yet. Unless it's actually used on the belt tensioning mechanism. See. Again, the specialty screw, I'll call it, goes in from the front. The other one goes in from the back. You know what? I'm going to leave that out for just a minute, and you'll see why momentarily. And I'm not sure. It called out for the M3 button head and an M3 hex nut. And I don't see where that's used unless it's the clamp. Might be to clamp the Z belt here. So now we're going to have a few more things, and I think we'll look for it and drag that stuff out when we get to it. Do not attach the X stepper motor before securing the Z belt to the left mount. Okay. Reload the 4 cart screws through the round opening. So we're going to need to get our cart screws added through here before we put anything else in here. Otherwise, we're not going to be able to get to them. And those screws are going to be hide that. Okay. Hide that. Okay. So we've got 2 M3x10 button heads and 2 M3x14 socket heads. M3x10 button heads. M3x14 socket head. Now, I'm gonna bring you guys over here. See if we can't show you guys. So in this part, you'll see there's these two cutout like trenches here. That's how we're going to get the screws in there. Same thing back here. There's these holes back here that we have to fit these screws into. So goes like this. Belt is towards the back, which means that this is the top, this is the bottom. The top has the button heads. So we need to see about getting the button heads in there. Button head. Two button heads. That one. And that one. So you'll be able to see we've got all 4 bolts showing up. So preload the 4 rail carts through the round opening. Screw the mount to the cart using the hex key access holes from the right side. Okay, so we're going to have to come all the way through the printed part to get there, which means we're going to have to use their tools because my tools are not going to fit through those holes. I know because the shaft is bigger than the driver head. We're on a standard Allen key. They're going to be that nice long Allen key head. So grab these and which is which. Head. That's the right one. I think these are going to be too long. Works for the smaller, or for the socket heads. There's the one for the button head. I'd used one once before, but bigger, bigger. This is one I just used. This is too small, or at least was feeling too small. Looks way too small. Thinking that was in the package, it wasn't, so. Oh, yep, that's it. Good. So now we'll get this one lined up. Get in there snug, maybe. Yep. Dug it that way. Dug it that way. Ugga that way. And ugga that way. Still slides up and down nicely, so that's good. So we screwed the cart using the hex keys. Insert the hex nut into the side opening of the Z-belt clamp. Hex nut is once again an M3 hex nut. So probably could have told me to do this before I put it on. And I just threw a hex nut on the ground there. Okay. Appears to have gone in partially. Hex key to make sure it is in there fully. So that's that one. I'm going to go ahead and put the one in over here on this side as well. Same type of thing. I'm having to use a pair of tweezers to get it lined up, and then I can push it in some, and then I got to push it in the rest of the way. It's just one of those things that it's right up against the back edge of the printed carriage part. Okay, so those two are in. Attach the Z-belt and tighten the securing screw that goes into the hex nut. Okay, and this is going to be 9 mil belt. So we'll grab our 9 mil belt. What time is it? 9 o'clock. So once again, we'll open this up. And let's see, does it go the full up and down or? Keep saying this is 9. This is 9 mil. This is 6 mil. The 9 mil is only at the y-axis. Let me wrap this back up and put it back away, and I'll grab the 6 mil belt again. Everybody's being pretty quiet tonight. I hope everybody's alive and I didn't lose a bunch of people. I know, what was it, Mandic was streaming tonight. His was he doing the Milo, or he was doing something. I can't remember what though. I think what I'm going to do is try and come underneath and around the pulley, the lower pulley. We'll pull this around under the lower pulley, pull this up, and I believe it only goes in halfway and does not go in the full way. Yeah, I'm pretty sure this looks like it's a full belt. It is not a full belt, so to speak. So I've pulled the belt up from the bottom. I need to get this lined up and pushed in. And I'll bring you guys around here in half a second and show you what I'm doing. So we've gone ahead and pushed this underneath. What I did was I applied some pressure to the backside with my tweezers, like so, to get those teeth in the pulley, and then I was able to rotate the larger pulley here. Whoops. Rotate the larger pulley here, and it will bring the belt around, bring it up, and we're pushing the belt into the bottom half. It's going to come up, loop around the top idler, come back down, get cut and go into the top half, and then we'll secure the screw in, and that will keep the belt in place. All right, we're going to wind up doing that on both sides. Same type of mechanism on both sides. Bedtime here, Chewy. It's 9 o'clock. You're like getting weak and going to bed early on us here? Okay, now it did say in the instructions, attach the Z-belt and tighten the securing screw that goes into the hex nut. The screw is only intended for extra safety. Tensioning it at a high torque will crack the part. This step of the process, you might need to trim the Z-belt precisely. Okay? So that's telling me that we're going to need to bring the Z-belt up, or at least figure the rough length of the Z-belt. Again, I'm going to go a few extra teeth. Cut this. Now we've got our tensioner up here at the top. I'm going to barely get a couple of threads on it, push down, and I'm going to bring this, yes, around that tensioner pulley at the top here. Come on. Okay. Well, I know Maker Milo, when he did this, said it was easier just to basically pull it completely out and wrap the belt around it and then stick it back in. So that is exactly what I'm going to do. I should have probably also figured out the number of teeth so that both sides were the exact same tooth count. Because what I just did was, if I don't do that, then my belts will be different lengths, and that could wind up being bad. Or not bad, but make it harder to get even tension between the two sides. So we've got one side. We're going to do our matching teeth trick. So the one that we've cut starts at the top, and the next tooth. So this is the cut one. This is the one that I'm going to cut to match this length. So I'm going to start off with the first tooth here into that groove. And then by just pulling it, just making sure that we stay in the grooves all the way down. When we get to the end, the first exposed tooth is where we're going to cut. And that will make these equidistant. There's some extra belt. So I now have two belts that are equal. So that will ensure that both of my Z belts are the same. Once again, here's that trick. I'm going to start to take this and put it through the pulley here. I'm going to take my tweezers and apply pressure behind that belt so that it pushes into the teeth. And as I rotate this, it's going to pull my belt through, provided I get my belt lined up and some tension on it. I don't know if you guys can see, but there's the belt. I just pulled it all the way through. So now we're just going to pull it through, get it lined up, and pushed into belt grooves on the bottom. Use our tweezers to make sure and push it all the way in. Loop our, make sure we get it in the right direction. Push it all the way up. Get a few threads going on our tensioning knob. And then we'll get our, darn it. I did cut the belt a little bit short, so I'm not going to be able to get all the teeth in for the top part, but that's fine. That is fine. And you can just twist the belt a little bit out of the way to get to the screw to insert that screw. Now what I'm going to do is pick this up and flip it around, and you should be able to see a little bit easier when I do this next one. Okay. Again, we want to get our belt around the bottom pulley here. So we're going to take that belt, try and get it started up underneath there as far as we can. We'll take our tweezers, stick it down along the back side of that belt, and then we'll just rotate our large pulley here, and provided that we can keep it straight, we'll pull our belt through. Well, through far enough. There we go. Got our belt through. I'm going to leave like an extra tooth from having it in the full position at that end. Got to push your belt all the way in. And once again, go ahead and remove the bolt at the top. Push it down and out. That'll make it easy to loop around that top belt. And once again, we're not going to take this all the way down to the bottom. We're going to leave a couple of the thingamabobbers open, a couple of the teeth grooves open. Push that belt all the way in. And we'll bring this up, line it up, push it in. Got our screw hanging up. Get it started. 4 a.m. wake up makes you old. No, that doesn't make you old. It just sucks. I don't know why this. I mean, I do. Let me pull a couple of these back out. So what I'm trying to do is this piece has a little mark on it, but that heat set doesn't go all the way through. So I've got to get it long enough that I can get it in and threaded into the heat set. And then I should be able to use those marks to tension the belt. Right? These are fairly tightly tensioned now. What we need to do is put the screw in that belt clamp, which is an M3 by 12 button head. And once again, this is going into that hex nut, but we don't need to ugga dugga the crap out of it, right? This is just applying a little bit of extra clamping force. The belt is being held in by the teeth in the printed part. Right now, we're just applying a tad bit of tension. If we do too much, we will crack that part, and that's not what we're intending to do here. So we should be able to just rotate that out of the way, push that in, get it snug, and then I'm doing like quarter to a half turn more, and that's going to give me all the compression that I need there. And now these are linked to the Z-axis. Okay. So we got the Z-belts. At this step of the process, you might need to trim the Z-belt precisely. We did. Insert the X belt loop into the mount, and then insert the stepper motor with the pulley while keeping the belt in the right place. The X motor pulley requires a 1.7 millimeter offset from the stepper face, with the middle of the belt sitting at a 13 millimeter offset. Okay. Motor, check. Pulley, check, check. Bearing, check, check. We need to put some Loctite on our set screws. And Chewy, yeah, the 4 a.m. wake up, that does suck. I have not had to do that in a long while. Like I've been doing the 4 a.m. wake up or five. Actually, I would do the 4 a.m. wake up if I'm heading to the hunting property first thing in the morning. Then I would go back to my parents' house, which is an hour closer, and then spend the night there if I'm doing a multi-day set. So we're going to get this lined up. I'm going to start snugging up that side a bit. Now, I'm not going to measure 1.7 millimeters. What I'm going to do is get this mounted and eyeball the darn thing. Right? Let's be honest. I am not going to eyeball 1.7 millimeters down there. I know that that's longer than it needs to be. I mean, we can probably look at 13 millimeters to the center. That probably wouldn't be that hard. In fact, that would probably be the easier way to figure it out. Mark 1 eyeballed. Mark 1 eyeballed. I basically put the ruler here at 13, was kind of trying to line it up here, made sure from here to there was about 1 point something. And so that looks about right. Um, 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 um. Insert the X belt loop into the mount. Insert the stepper motor with the pulley while keeping the belt in the right place. The X motor pulley requires offset. It looks like there's a bearing that goes at the end of this. Stick that bearing in there or on there. Okay. Secure the screws of the stepper motor. Temporarily insert the X extrusion into the mount and check for clearance between the pulley and the extrusion end. Attach the double shear insert while making sure it clears all the inner components. How is that? Ah, the whatever that little weird looking. This also looks like it's going to get M5 screws, and when this goes in, all right, yeah, we'll be able to get to the one over here. Okay, so we'll need to get the belt looped around here. How is this? Goes through the top. Come on. Go through there, and then there's a exit hole out the bottom, I believe is what it's going through. There you go. You go in that way, out that way. There. I think that's how it's going to go. Push that through there in a nice big arch. What screws are we using for this motor? M322, M335, M335. And a small button head from the other side. It too difficult. Sorry here, folks. I'm trying to. M3 by 8 going to be in this top one. So M3 by 8 button head. M3 by 35s for the bottom two. Socket heads. M3 by 22 for the top left. Okay. We got all the necessary screws. Our motor wires are coming in from this side, not down, but from this side, because if we go down, we're going to cram our wires out that way. So we need to make sure that when we put this in there, it goes around the belt. You have the belt around it. And it was 35s at the bottom. Okay. Hey, Zombie, how's it going? Yeah, this is a blast. We're using CAD, some Midland instructions. But we're getting there. We're getting there. Part of the stuff that I'm having to deal with is just making sure that I get things in the right order. There's a couple of things we had to, I'll say, undo because we went in with the wrong order of operations, but we got those squared away pretty quickly. How about you? Is the black box coming together and looking like a printer more and more these days? Okay. So those two are in there. We're going to pull the belt somewhat tight. I should say not tight, but taut. We want to put the 20 millimeter extrusion in here. This will be the X gantry extrusion. So I'm going to just try and, once again, pull this a little taut. This sits down in there. And what we're doing is making sure that there's no issue with the belt. And does not appear to be. Still on the bed frame. Hey, I get it. I get it. Okay. We're going to have some M5 stuff. Ooh. Wait. Where is that? So this is the piece that we're going to be putting in that kind of guides some things. There's a heat press that goes in there that we need to add. We'll have to put that heat press or that heat set insert in. Let me move this down so I can get the heat press insert up here. But yeah, we are making some good progress here, Zombie. It has been a productive day so far. That heat press insert is the short or long? Short. The thing with the bed frame, Zombie, is also make sure and double, triple, quadruple check the orientation of the kinematic bed mounts. I had mine off and I thought, oh, no big deal. It was a big deal. It threw a huge deviation on the bed, and the when it does the bed probe, because it's using the actual like gantry head and that little end stop, it's literally using a 1 millimeter um, gap to do the bed mesh. And I was having all kinds of issues getting it to bed mesh. And that's what it was um, the Kinemac bed mount. So as soon as I fixed that issue, boom, problem gone. So it's the Mandala Roseworks kinematic bed mount. They have to be in the right spot. And if you want, I'll take the bed off and take a picture of mine, because if they're not in the right spot, you will not have enough clearance for when it's doing the bed mesh, and then you'll wind up. I mean, it's only messing with the bed, but yeah, it's messing with the bed. Okay, so we've got that. We're going to wind up putting that in. This is a M3x12 socket head. Get rid of that. Oh, and hold on one second, Zombie. I want to show you something. Where to stick it? Ah. Here's our external remote um, uh, electronics box. Hinged with filament, sealed with magnets. We've got our FISEC spider board, our Raspberry Pi at the top, 48 and 24 volt power supplies in there, and some 60, what are these, 60-20? Yeah, those look like 60-20 fans that are cooling everything. That right there is like the only thing that concerns me, is whether those wires will get in the way of the fan. But yeah. Very nice setup. And I now understand fully why you love that ambrosia filament. It is amazing. Oh, that's the ambrosia that you like. Your what is it? The sparkle midnight meteorite. And then the other color is um the Cookie Cad ABS that is dark magic. So it's Cookie Cad dark magic and the ambrosia midnight meteorite. Okay, so this piece is what's going to go around the bearing and hold it in place. Now, the question being is whether or not it would have been better to put the bearing on and then stick this around and try and set it in there, or the other way around. So this heat set insert is going to line up with a hole there. So we need to make sure that that is down. And I'm sorry, that was M3x12 socket head. One of these. And Okay, it's not in there far enough. I think the better option here would have been to maybe put the bearing in the printed part, because I am using a soft blow hammer. Do not use a hard blow, you will bend your shaft. And I'm also praying to the gods that I had that lined up appropriately. Because that could be the other thing too, is I didn't have the hole lined up. I'm gonna say I had the hole lined up well enough. All right, there we go. Now, was there another screw that came in from the other side? Not apparently. The next step. The M5 screws and T-nuts depicted in the image below should be attached only when instructed during the final X gantry assembly procedure. Okay. So what we just did was this part, and I had pre-installed this on the shaft. What I should have done is press that into this piece and then press the whole thing onto the shaft. Probably would have been a little bit easier, but we're on there. X gantry. It has not told me at this point to insert the X belt loop into the mount, insert the stepper motor pulley. The X motor pulley requires an offset, blah, blah, blah. It has not told me to do the X belt yet, so we're still leaving that dangling. The M5 nuts and screws we won't use until we go to install the gantry. We haven't done the end stop yet. The end stop will go on using a hammerhead T-nut. So that's all right. We will add that on top of the gantry and slide it in eventually. We have to do some things on the end stops because they are see, Y end stop, right? This is the Y end stop, I think. Looks like it. Yes. Okay, it mounts this way. So the end stop goes in that hole. The end stop already has wires soldered to it. Those wires, believe it or not, there is a channel that comes out this way with the wires. So I think what I'm going to do is I'm going to cut the JST, like I'm going to depen it and cut the JSTs. I'm going to fish the wires this way, because what they tell you to do basically is desolder the wires, fish the wires in this way. Well, on this particular one, you're going to get both your wires that come through. On this particular one, it's going to be hard to show you. but there is individual holes for each of the two end wires, which means those wires come in and kind of do this, right? They're coming in and then do the loop around to each side. I'm not going to be able to easily do it like this. It's going to be easier to feed them in from this side and let them follow the groove around. So that's my plan. That's why I haven't done any of the end stops yet. We can add those later. They'll be an easy tack on. The X gantry requires a series of special steps to ensure proper installation. Please read them carefully. Make sure to leave a gap in the following places to permit movement during the Z-tilt procedure. So we must leave a little bit of a gap there, and there needs to be gap between the printed part and the rail. Okay. Preload the extrusion with 2020 M5 square nuts on each side. Slide in the tool head cart onto the rail, but do not attach it to the belt module. Insert the X extrusion into the mounts. Push the X belt into the bottom extrusion groove. Check the left and right places. Make sure they are even. Press down the extrusion to ensure it sits flat. Then pull it towards the front so it's aligned against the mount's front wall. Loosely attach the screws, blah, blah, blah. So, a lot going on there. First things first, we're going to pick this up and put it down on the ground. Move it as far out of the way as possible so we don't trip over it. Remove our bangy thing out of the way. We're going to grab our last linear rail. Glove. And apparently another couple of paper towels, because we're going to be lubing a rail. We're going to lube and mount a rail again. So I'm going to look at the rail and see if there's a bad side. I don't see a bad side. You know, I haven't seen Pez List tonight. He has been either very quiet or not on, which is weird. And like all the other rails, this is basically dry as all get out. Oh, she's streaming. So, I mean, there's some type of oil because I do have a sheen on my fingers, but that is the lightest amount of machine oil I have ever seen, if there's machine oil on it. I am going to wipe off that rail with some alcohol to get whatever that is off, but going hard. Oh, that's right. That's right. She's trying to. So, for those of you that aren't aware, Pezliz has been, I believe, invited or has received the initial invite for Twitch partner. So, in order to do that, she's got to get a certain number of hours worth of streaming for over a month. Like a certain number, you have to stream a certain number of times and a certain number of hours. And then you also have to, have 75 people on average across a certain period of time as well. and that's 75 people per stream average. So if you have an opportunity, please go and hang out on Pezliz's stream, and let's help get her partner push done. Oh, let's put that back down because I about grabbed that for a drink. That would have been bad. Let's get off of that view for a minute. We'll go to this view. And once again, we're going to prep this rail. We just wiped that rail down, so that's nice and good. We're gonna lubricate the bearings. So we're going to get our glove on. And we're going to pop out our good old EP2. We're going to beat on both sides, and then we'll press it in on both sides. We'll move the balls through the cycle to get this grease moved around into the races in the carriage, and then we'll do this again a second and third time. What you see me start to do first is I push that grease into the balls, and then I will move the balls through the races a couple, 3 times. And that's going to distribute that grease around the balls and into the races. And we'll do this 2 or 3 times. And that will ensure that we get a nice, good coating of this EP2 grease in here. I know some people will be like, no, you need to use white lithium grease. You need to use this, that, or the other. In this case, it may be worthwhile to go and spend the extra to get the really good high temp grease, because with the speeds we're going to be putting this at, it's going to heat up, right? Also, if you wind up putting this in an enclosure, now you're adding additional heat in there beyond just the friction. And you'll cook the oil off fairly fast, or the grease off. And that's another reason. Some people do oil. It's too light and viscous for me, because if you run it in a chamber, it's going to cook off a lot quicker. And we do tend to run our borons in chambers here. You put the full enclosures on them, so. Okay. With that said, I'm going to wipe off some of the excess here. Cover back on. And we're going to slide our rail back on here. And I get my rail started, and I slide it on slowly until I see the balls start to bulge. And then I put my finger down in. On a MGN9, just having the finger in sideways works. This way it's a little bit bigger, so I'm going to kind of do a little bit of a twist. And I'm going to pull my finger back through the channel as I slide the rail in. And what that's doing is pushing on those spring clips that are holding the balls in. And if you do this right, you don't get any balls released. Now, quickly check your glove, check the end, make sure you don't have any balls sticking out or pending, like getting ready to. And as long as you don't, you're good. Go ahead and work that on the rails and side load it some when you're doing this. Side load both sides. That's really going to work that grease down into this channel. So those balls are riding in this channel. Not riding on this edge. It's not riding on the top, the bottom. They're riding in this channel down here. So any grease that comes out of that channel is really just going to be something that can get in the printer or flipped around. So you're going to see me wipe that excess off. I didn't put my fingernail down in that channel because that's where I want the grease at, is down in that channel. Um, I will wipe across the face of this slightly. And all I just did there was ensure that the excess grease that was on there, I now have a light, very, very light coating because I didn't, press down and really wipe off. I just kind of spread a very light coating of oil or grease across this. And you will see me periodically from time to time come back in with some 3-in-1 oil with PTFE lubricant, right? I will just get some of this on a towel and wipe the rails down with it. And all we're doing there is ensuring that we're getting a light coating on the rail so the rail itself doesn't rust. If you're getting a good high quality rail, it shouldn't rust. And I would just say, yeah, we're getting kits from overseas. They're packed in a ton of oil normally because of the, it's coming over on a boat, salt water. They don't know how long it's going to be on the water or in the port before it gets to you. So they tend to really goop them up, and you want to get that goop out. These were not really gooped, which was nice. But we do want to make sure that we are getting these things cleaned and lubricated appropriately. So what I want to do is I'm going to grab that and I'm going to hide it. I'm going to try to grab that, hide that, because this lets me see if we're doing every one or not. And it looks like we're doing every hole on this rail, which is nice. Those are going to be the 2020, not M5, 2020 M3 square nuts. Because these are going to use M3 by 8s, or I'm sorry, M3 by 10s or 12s most likely. So we've got 2, 4, 6, 8, 10, 12. So we're going to need 12 of these in here. And how's it going, Daisy? All right, so there's 12. Oh, and Daisy, I will be reaching out to you very shortly. For those of you that have been following along, you may have heard me make comment about some things that were in the works. Well, as of this afternoon, I happened to do a query, and according to the North Carolina Secretary of State, Digital Dragon 3D LLC is now a legal entity with the state of North Carolina. So that means we will be working on some new things here shortly. What I'm going to do is I'm just going to grab one of these and I'm just going to eyeball line these up. So for any inquiring minds, no, that does not mean that I am not doing my other job. I still work for Cisco Systems on a daily basis. I plan on riding that gravy train until they either seriously piss me off or show me the door. Either way, I you know, I am going to continue on my 3D printing journey and doing the things that I love here. So, okay. And the screws, get that screw from this, not the screw. M3x8. Okay, socket head. That looked like button head there for a second. I was like, huh? Okay, but that's a socket head M3x8. Bunch of those. Yeah, so I'll be reaching out to you now that that's a true thing, because I wasn't sure that I was going to get the name that I asked for until, everything goes through. So now it looks like that name is good. It's mine. So, and just like everything else, we are going to put some thread locker on these screws. Once again, I know a lot of people will be like, why are you doing thread locker on that? Well, when you see the speeds that this thing is capable of going at, you'll know why we're putting thread locker on everything. The amount of potential for vibrations on this thing is very, very high, to say the least. So yeah, you're going to want Loctite on everything. Don't use Loctite Red. You use Loctite Red, and well, yeah, it's permanent at that point. Not going to come off. But yeah. Now that I got the name, I'm going to be looking at doing some branding stuff. Maybe some additional merch. Like Digital Dragon 72 is still going to be a thing. That is me. But I will be looking at most likely renaming, going through a rebranding effort on the channel and a few other things. So and I am not tightening these down at the moment. I'm just getting them started because I need to make sure that I get all of the screws aligned first. There might be some slight alignments with the T-nuts underneath. Hopefully get to see some zombie hedgehog tonight working on a black box. Now he was doing some content on the Volvo SV06 Ace. Seems like people that that have worked on that Soval or been with, not with, but that have gotten the Soval SV06 and, from the influencers and stuff, that they seem to like it. Um, I know I've seen a lot of unboxings and stuff like that, which, okay, great. Everybody was also saying the Cheaty, the Cheaty Tech 4 Plus Max, whatever, was really good and great as well until somebody realized that the heaters were kind of going south on them And by heaters, I mean it was the SSR for the chamber heaters that were not doing things they should and running a potential fire hazard. So, you know, you got to put a little bit of time on printers that are new to the market. Um, in this case, well, especially commercial printers, right? In this case, I'm building this printer. I'm making sure that I'm using good solid connections here, there, and everywhere, and appropriate wire gauge, following the minimum guidelines. And, you know, it was showing that we wanted, the wiring kit for this was showing like daisy chaining the mains power into the, um, well, with the way the wires came, it was really showing like daisy chaining two fork connectors on top of each other and daisy chaining the power supplies together. Yeah, no, we're not doing that. We go through and we will uh, properly use Wagos and get those connections. So what I'm going to do is I'm going to try and get an even amount on each side here, because we're trying to leave the same gap on each side. I think if I can get the gap measured close here. All right, I'm about 11.5 millimeters on each side. Got 12. There's that one. These two will go over here on these ends. Keep everything lined up. Again, we're 11 millimeters, roughly 11.5 millimeters on each side. So that should be good. Now what I'm going to do is I'm going to not ugga-dugga these down. I'm going to go through and snug them down first. Now that that's done, I'm going to start coming through and putting a little ugga-dugga behind all of them. Okay. So now we've got our gantry in place. Gantry. We've got our linear rail in place. We'll bring the printer itself back up here and double check to make sure that we've got the gap on each side. If we need to, we will adjust, but we'll adjust in place. Now, I understand that the gantry is going to be facing the front, and my M5 screws for mounting it to the plastic parts are going to be the front and the back. So I'm going to grab the M5 slide in T-nuts, put that there. 2023, 2020 M5. Now the ones on the back, I can pretty much slide wherever. They don't need to be right at the end. Because I can always slide them back out. So set that there, get this out of the way. We'll bring the printer itself back up. And we currently have the gantry way up at the top. Not sure if I'll be able to set this in. We'll see. Okay, we set that in. And we're making sure that we've got a gap on each side and at the front. And we do. Let me bring y'all in to show you. So we've got, whoops, switch side camera. Okay, so we've got a bit of a gap right there, as well as between the printed part and the rail there. Same thing over here. We got a slight gap there at the front, as well as one here between the printed part and the extrusion itself. So that's good. We appear to be about equidistant from a base eyeball there. So that's somewhat good. We can use a Allen key to kind of line these up. Once again, the back ones will be easy enough to slide in. Let me try and understand what it was telling me to do. 1, 2, 3, 4. So press the extrusion to ensure it sits flat, then pull it towards the front so it's aligned with the mount's front wall. Loosely attach the screws. We want the extrusion to be able to tilt freely. Attach the end-stop mount, leave a small gap to the left side to account for the extrusion tilt method. Ensure the screws sit on washers and then tighten them in the following order: 1, 4, 2, 3. Okay. So the front on at least this side was the short one with the funky M5 head. See which okay. Got that one there. This one goes in the back and it'll be the next size up. So we'll need to move this one over to get it lined up. We'll add this screw from the back. And that is not biting. I feel like it is, so why not? Lined up, not biting. Feels like it's not long enough. Should be long enough. Hey. Oh, you know what? I think this is the one where I was told you need to go one size up because the screws have a chamfered end and will not engage with the part. So these screws right here have a chamfered end on them for the first couple of threads. So if you use the size that it calls out for, you will not be able to get these to engage without doing some shenanigans. These are M5 by 12s. So if we go and grab some M5 by 14s, that would work. Do I have M3 and 3, M5 by 14? Five 16. And let me see if we've got some M5 14s. Okay, we don't have M5 14. The only M5 14s I have are button heads, not the cap heads, and they're silver. They're not black. So meaning I might have to go and get some additional screws or potentially try and set this on its back some and allow what's happening is it can suck it up, but once you let the screw back out, it kind of falls back some, which means it can't pick it up again. So I think I might have to tilt it back to let the T-nut fall some into the extrusion, and then we'll be able to tighten it down. So on the left side, what screw are we using? M510 as well. 510 low head. And assume that it gets another one of those small shims. Most likely M512 from the backside. Okay, we had the 570. This is the thin one that went. And then a 510 went on the back. Okay, so now that's in there. I know it's not going to come out. What I'm going to try and do, like I said, is I'm going to turn this around so it's facing me. And I'm going to try and tilt it some off the back here to see if I can't get the nut to kind of fall forward, and I'm able to capture it there. So that worked. We line this one up and do that over here on the other side. Okay, well this one captured where this one was pain, so that was in. Ugh. So they're a little snug. I haven't tightened anything up yet. I want these all the way up, so my carriages are all the way up at the top, which means this should be straight and parallel. This should be equidistant right here. Okay. Ensure the screws sit on washers. They do, and then tighten them in the following order: 1, 4, 2, 3. So we're going to do the front and the back on this side, and then we'll do the front and the back. Or wait, yeah, 1, 4, 2, 3. So I am putting a little bit of quote unquote ugga dugga here, but not a whole ton. I'm not trying to snap these parts here. I'm just trying to snug things up and make sure that they're good and snug. So the front 1, 2 screws require a medium torque, where the rear 3, 4 require a low torque. This is ensure that the gantry. So, all right, that tells me what I need to do is loosen these up slightly on the back, because they need to have a lower torque on the back to allow the gantry to be able to flex a bit. So there we go. Medium torque on the front 2 screws, low torque on the back. We will crack this back just a hair. That. Insert the loose side of the belt into the tensioner module and make sure the recommended tension can be achieved using the tensioning screw. Okay. So the tensioning module is this right here. Got the little belt in it, or the belt grooves in it, and it gets a whatchamacallit, it gets a heat press in the one side. So good way to show this. I take that piece and hide it. There we go. So this is that tensioning module. So there's a very long M3x40 screw. It goes through a printed part, and inside this printed part on one end is going to be a heat press insert, and it's going to be of the long variety. We'll need to put a long heat set insert in here. So let's move this down so that we can get that put in. Now I've got 2 of these. I don't know why I have 2 of these. I'm saying that like I wonder if I should just go ahead and put a heat set insert in the other one while I'm doing this. Kind of makes sense. Long heat set. I worry about how thin these are. Very, very, very thin wall on this. See what I mean? Very, very thin wall. We got a little bit of a bulge there, so I need to try and push that bulge flat all sides while it's still pretty warm. Um, and like I said, I think I'm just going to go ahead and do the second one as well. Can't hurt. Just last words, I know. This one uses a nut. So good there. And what was this again? This is an M3 by 40. M3 by 40. Hey, Gulsifer, how's it going? Hope you're doing good, my friend. We are, well, we're getting something that's looking a little bit more and more like a printer every day. So this belt is going to go through. So as you can see, we're pretty long. Doesn't need to be that long. We'll need to be able to get tension and tightness. So I am going to right about there. We can cut this. Yeah, and we made sure that that was going to be long when we were doing this because we just need to make sure it was going to be long. So what we'll do is we'll take our piece and we're going to start by running the screw through it to clear out all the plastic swarf that is now in the way. It's going, yes. Yes, I feel that sentiment. Getting close. So this is what I'm talking about by plastic swarf. This is plastic that got pushed. Whoop, there it went. That was plastic that got pushed down into this channel. And this screw needs to be able to go through this channel and into that M3 heat set insert. So if that plastic was in there, it's going to keep that from happening. And we're never going to be able to get this thing tight. Now, the heat set side is at this end. So we're going to take the groove side here, lay it on the belt. I'm going to lay it right at the end. Right, put that belt all the way in. Angle it and push it into that gap there. Be somewhat tight, but you'll be able to push that in. Or you'll push it in and you'll do what I did, which I just split the part right at the layer line there. Means we got to take this off and reprint it. Dang it. Dang it, dang it, dang it. Because that's not going to be good. We don't want that to be split. That will cause us problems. I wonder, it might have been that little rise from the heat press insert. But we're going to have to take this screw out. Luckily, that's all that we've got in it so far is this screw that goes around the loop here. But I am going to have to reprint this part. There is not going to be a way to salvage this reliably. Dang. Yeah, so we'll try and use this one next time. Maybe I'm going to heat this up and try and press it flat even more. There almost needs to be a little bit more meat there. What am I dragging on now? Hmm. Starting to wonder now why I'm dragging here. Hmm. We're going to need to figure that out as to why that's catching and dragging. That's like seizing right there. Oh, because you know what? I wonder if it's catching the, it might be catching the gantry there. That might be what's causing that. So we'll take the gantry back off. We're going to have to do that anyhow to make it easier to work on that X belt. But yeah, I'm gonna have to reprint that part. Now here's a question: do you guys want me to reprint that part in the Dark Magic, or do you want me to reprint that part um, in the Midnight Meteorite, this color? Not initially seeing anything, but this motor is fully seized up in there. Makes me worry about this front bearing that I pushed that plastic part onto. So let's see where are we at. We're at 10:30, folks. I think it's about time for us to call it a night. Let's. I'm gonna have to reprint some parts. We'll come back to this on Saturday. But thank you guys for being here. Let's go over. If she's still running, if Pez is still running, we're gonna head over there and see Pez. But thank you everybody for being here. I think we've made a lot of good progress here. We've got the bed getting together with the epoxy. That should be fully dry, well, should be dry and fully cured by tomorrow. So when we come back in on Saturday, that's what I mean by plastic swarf that got in there that would foul that thread pattern. So by Saturday when we come back, we'll be able to get the bed installed. We'll figure out this gantry. I'll reprint anything that needs to be reprinted, and we'll go from there. But right now, I've got to figure out why this this motor's binding. So yeah, let me get this raid started over to Pez Liz. We normally go over to Jano, but if Liz is up and running, like I said, she's trying to do a partner push. So we'll go over to Liz. Are you Liz? She's not on? Oh, well, if she was streaming, she is no longer streaming. So with that being said, it is Thursday night, which is normally Marble Night, over with Big Jano. It looks like he's working on his gingerbread house. So we'll go ahead and get a raid going over to Big Jano. Thank you so much for being here, everybody, and hanging out with me for a few hours as we continue to work on this. I'll figure this part out. I don't know why this started binding all of a sudden. We'll get that figured out, and I will print the part that we busted and try and make sure that we don't bust it the next time. But thank you everybody for being here, and I will see you guys on Saturday morning. Bye now.